Welcome. If you're passionate about power systems, substations, transmission lines, and everything that drives the world of electricity, you're in the right place. Here, we break down complex electrical engineering concepts into simple, practical, and engaging explanations. Whether you're a student, professional, or just curious about how electricity powers our world, these videos will help you learn and stay updated. So stay connected with the world of electrical engineering. For understanding what an electrical potential relay is, let us first examine a simple circuit. This is the circuit breaker, shown in the closed condition, and this is the current transformer. What you see here is actually the secondary circuit of the current transformer. It is connected across an electromagnetic coil, and that coil has a plunger which is normally in the open condition, meaning it is a normally open contact. This is another coil. This coil belongs to the circuit breaker mechanism and is called the tripping coil. Here is the battery source. In reality, in a substation, it is not just a battery, but a charger that supplies the DC current, with the battery connected across the charger as a backup. For simplicity, we have represented this power source with the symbol of a battery only, omitting the presence of the charger. Now, suppose a fault occurs at this point. Due to the fault, the current from the source will pass through the primary of the circuit breaker. As a result, the secondary current of the current transformer also increases. This increased current strengthens the magnetic force of the coil, which attracts the plunger and closes the circuit. That means the DC trip circuit of the circuit breaker is now closed. As soon as the circuit closes, the trip coil gets energized. It attracts its plunger and operates the mechanism to trip the circuit breaker. This is the simplest theory of electrical protection and also the simplest model. The portion within the orange box represents the electrical potential relay. So, an electrical potential relay essentially has an electromagnetic coil and at least one normally open NO contact. Do not misunderstand this as the actual relay. Real relays are more complex than this simple form. But to explain the very basic working principle of a protection relay, we have represented it here. This example shows an electromechanical relay. Nowadays, solid-state relays are also available in the market for the last few decades. The principle is similar. Instead of a relay coil, they use solid-state semiconductor devices that are controlled by current. When the CT secondary current increases and crosses a threshold limit, the semiconductor device triggers and electronically closes the DC trip circuit of the circuit breaker, thereby tripping it. So the basic working principle of both electromechanical and solid-state relays is more or less the same, but their construction is different. We will discuss the detailed construction of different types of electromechanical relays and solid-state relays in a future video. Thanks for watching. We hope this video helped you understand electrical engineering concepts better. If you enjoyed the content, don't forget to like, share, and leave your thoughts in the comments. Stay with us and stay updated with more videos on transmission lines, substations, and power systems. Until next time, stay curious, keep learning, and keep the power flowing.